Right, well here I am. I'm using the same simulator as I was using before, which is called the PHET simulator from University of Colorado. Have a go yourself. Click download and you're pretty much ready to go really. What I want to show you today is something called series and parallel circuits, but I want to look at the current in them. In the last video we saw how it affects the brightness of bulbs, but now I'd just like to look at how it affects the current. And to do that we need to use a device called an ammeter. Now this ammeter here, very easy to use. You just move around and you say where you'd like to measure. Dead simple. Generally in real life you'd get one and you'd actually have to put it in place, you'd have to wire it into place there. It can be a bit of a faff, but this one's much easier because you can just move it around. It always goes in series. Now then, we can show you, we showed last time, didn't we? We showed the current going round. So we can see the current going around here. It seems to be going around at the same rate all the way. The electrons are travelling around at the same rate. So that is really telling me the current is the same everywhere. Now I can confirm that. I can confirm that there. 0.9. We've got 0.9 amps setting off from the going through the bulb. We've got 0.9 over there. 0.9 here. Coming straight out of the negative there, we've got 0.9. Yeah, it's 0.9. The current is 0.9 everywhere we go in that circuit. Now let's see what would happen if I were to stick an extra battery in. Stick an extra battery in or an extra cell, pop them in. Oh, it looks brighter. They look like they're moving faster. Well, coming out of the battery we've now got 1.8, so it's double. It's double what we had before. 1.8, 1.8, 1.8. Yeah, it's looking like 1.8 all the way around. So it's looking to me that in a series circuit, the current is all the same. Now, I'm guessing if I stick another one of these in, it's going to get even brighter. Oh, it is brighter. The current's travelling faster by the looks of it. You've got more current, but we can check it. But if one of them gave us 0.9 and two gave us 1.8, I'm guessing it's now going to be 2.7. Yep, 2.7. The current is the same everywhere in a series circuit where it's only got one way to go. We got 2.7 there. Okay, well let's see what would happen if I stuck an extra bulb in. Would it get brighter? Would it get dimmer? What would happen? Stick one in there. Well, straight away I can see they don't look quite so bright. So I'm guessing there's going to be less current, and there is. It's gone down to 1.35. It's halved, in fact, because the current has been slowed down by the two bulbs, and it's now half of what it was before. It's 1.35. Yep, it's looking like 1.35 all the way around. Okay, and I'm guessing if I stick another one in, it'll be no shock here that in a series circuit. Oops, I've put that in the wrong place. Let's pop that there. Yeah, maybe dimmer still. Yeah, it's gone down to 0.9. It's right back down to 0.9. All the way around. Same current everywhere in a series circuit. Okay. I can show you something else actually. I can show you something called a short circuit, which is where you get another route to go. If I give this electricity a route where they can miss out all those bulbs, it's going to go there. What do you think will happen there? Ah! It misses out the bulbs, and because it's got no bulbs, it goes through. It's on fire. Oh, look at the current. I can't even read that. The current is so great. And the whole thing has just gone on fire. It's generated. It's gone. Yeah. Don't do a short circuit, kids. So, recap. Series circuit. The current is the same at every single place in there. I would now like to look at a parallel circuit. So let's set up a parallel circuit. You may remember. Think to yourself, what did parallel mean? Hopefully you can remember. Parallel. Parallel means there's more than one route for it to go. So I'm going to go from here. Let's set up one. but nice and bright. We saw that before. So let's stick another one here. Ooh, well, the brightness hasn't changed, has it? The brightness is still really bright. It's got, take that out. The first one's not changed. The first, if we look at the first one, when it goes in, it doesn't change. Okay, let's look at these. That's going really fast here. They're going just as fast, but can you see one goes one way and one goes the other way? So I reckon there's more current in this section here than there is in here. Let's have a look. Let's get this out of there. So coming out of batteries, we've got 5.4. We've got 5.4 there. And we've got half of that here. 2.7, yeah, 5, yeah, that's half. That's half. So we can see that the current, it halves. Okay. Fair enough. Right, let's get that out. Let's stick a third one in here. I'm guessing that if we do that, so test it here, 2.7, 2.7. They're all equal. All the parts are equal, but they are all less than this point here and that point there. You got lots, and it splits up one way, splits up a second way, and then that splits up, and it splits up there. It's splitting up all over the place. Okay, and if I stick another one up here, I know it's generally they don't draw batteries like this, do they? They don't draw circuits like this, putting them up here, but we can quite simply put one there. And we find the same thing. It splits up. That's going really fast now. That's 10.8 whizzing through here, and then over here it's going 2.7, 2.7, 2.7. It splits up. That's now going 4 different ways. Right. What would happen, do you think? What would happen if I took this wire out and I put one here? Would this be brighter or dimmer? These two here, these two are going brighter and dimmer than the rest, and what will the current be in there? Well, they don't seem to be as bright. That's only got 1.35 now, and this is on 2.7. If I stick another one here, yeah, it's getting even less. I'm slowing the current right down here. Less current flowing. Not affected these though. So that is the current in a parallel circuit. Remember, series circuit, one way to go. Parallel circuit, 2 ways to go. Or more.